Yes, friends. So let me take this question here. Okay, these questions are based on cylinder and cone. Okay, so right circular cone, as I have discussed in the previous lecture series, that questions based on cuboid and cube. Okay, now in this lecture series, I'll take questions based on cone and cylinder. Okay, as I promised with you that I'll take some questions which are I've taken here 12 questions. I'll read each and every question, okay, loudly, and after that I'll solve these questions so that one can understand that what is written there. Because there is a problem, some of the students has asked me that sir, there is a problem in visibility or something. So I've tried my best to just visualize this whole thing, and I'll just make take a photo of this, and after that I'll submit it to the, I will upload this, and after uploading it, and then everything will be clear. But even then I'll clarify every question whatever is written here. Okay, so I'll read every question loudly, and after that I'll solve it with examples, with illustrations. What kind of illustrations? That how this question has been solved, what is the formula being used here. As I just promised with you, I'm doing questions as usual. Let me take these questions now. Okay, let me take question number 1. Okay, but before that, let me, as I always summarize, what the formula used in case of cone and cylinder. Okay, so let me first write what is the cylinder. First formula is for cylinder. Let me take cylinder, or this is known as right circular cylinder. Okay, right circular cylinder. Why right circular cylinder? Well, this is a straight one. It's a vertical height. It has just like a pipe. Okay, or electric tube. Let me take, this is a pipe type. Okay, and what is the pipe type? This is the circular top and circular end. Now this is the diameter of this, so circular end, just like a pipe. And this is the vertical height known as, this is the vertical height as I have described number of times. Okay, so this is the vertical height, and this is the radius r. If I take this as the radius r, because this total is diameter of the circle, so this is the circular end, just like a circular pipe. Okay, or if I just explain this, if I take a paper, which is a rectangular shape, okay, and if that rectangular shape paper is folded either in around the length or around the breadth. Suppose, let me take, I have folded it around the breadth, then the total breadth will be equivalent to the circumference of the circle, and the length will be the vertical height h. And then what is the area? Area, we know that what is this, in this case it is known as circular, circular area or curved surface area. This is known as curved surface area. Curved surface area will be this area of the base. This is circumference of the base. Why? Because this is circular or curved surface area. So curved surface area, first formula is for curved surface area. Curved surface area of a cylinder. Curved surface area of a cylinder is equal to, this is circumference of the base. Let me write here, circumference of the base into height, into this vertical height. Why? Because this is circumference. Now that breadth which was converted into a circumference of the circle, because if a paper is folded like this along the length, in this case I have taken along the length, okay, and then this total breadth of this has converted into circumference. So the circumference of the base, into height. This is the area of the curved surface area. Or in case if it is a paper, rectangular paper, then area of a rectangle is length into breadth. But in this case, breadth has converted into a circumference of the base, into height is the length. Okay, so this is circumference, or curved surface area known as curved surface area. So square unit. Now this is, let me write the formula then. What is circumference of the base? This is 2 pi into r, into height is h. So this is 2 pi r h. 2 pi r into h, where r is the radius. height is the vertical height of the cylinder. Okay, and this is 2 pi r h square unit. Now square unit means centimeter, square meter, square millimeter, whatever. Okay, so whatever unit is given to us, in that is square, because two lengths are multiplied, r into h, length into length. So this is meter square or centimeter square or square unit we just write. So this is curved surface area of a cylinder. Now second point is total surface area. Second formula which I have described in the 13th I think lecture series, because 14th and 15th I discussed questions based on cube and cuboid. Now I am taking cylinder and cone. Questions based on cylinder and cone. Okay, so this is right circular cylinder or right circular cone we are discussing about. Why right circular? Because this is a straight one. I mean, the base is just a straight type, or right is having a not the not you may say not lying on an angle or something. This is just a straight line. This is a right circular cylinder. So if it is having just a vertical height, then it is right circular cylinder. So total surface area, then what is total surface area? Second formula used for this is total surface area. The total surface area of a cylinder, and that is equal to this curved surface area plus area of the base and area of the top. But the area of the base and top, the base and the top both are same, but they are circles. So two circles. So area of the two circles, both ends, bottom and top, is also added up in the curved surface area. Total surface area is curved surface area plus area of the two ends, Okay, so area of the two ends. In that situation, we have to write curved surface area, which is 2 pi r into h plus area of the two ends, because this is pi r square, area of the circle, plus pi r square, that means 2 pi into r square, area of the two circles, top and bottom, which are the circular form. So area of the circle plus area of the circle, same circle. So this, in this case, we can take 2 pi r common, and this is r plus h or h plus r. We can write r plus h. Let me take square unit, because this is area again. So this is the square unit. Okay. So area is the total surface area. This is second formula which is being used. Now let me take what is the third formula. Third formula is for volume. Now third formula which is used for cylinder is volume of the cylinder. Volume means what the quantity is being held by a pipe or a cylinder in this case. Okay, so pipe is a cylinder. That total quantity or total amount of anything which is held by this cylinder is what? Total volume. Or if it is a solid cylinder, suppose solid cylinder, what is the quantity of the metal, okay, is in this, I mean this cylinder is made from which quantity of metal. So what quantity of metal? So that is the volume. So volume means third formula is used for volume, and the volume of a cylinder. Volume of a cylinder. This is the third formula used. Okay, so let me decide what the volume of the cylinder. And volume of the cylinder means in the situation. So now in this case, what is the area of the base? Now area of the base into vertical height h, that means total quantity. Why? Because area, if I find out of the base, that means we have included what is the total material by which the base is being formed, the circle is being formed. So area of the circle of the base into height. Okay, so this is, or we can say that suppose I have taken a circular disc one upon the other. This is circular disc of metal, suppose iron, and then of 1 unit or 1 centimeter thickness. Okay, then another is put upon this, third is put upon this, fourth is put upon this. In this way, 10 circular discs are put upon each other. Okay, that means then what is the height? So 10 centimeter height. Okay, so that means that circular disc is the solid one. In this way, the solid cylinder will be formed. total quantity will be calculated what is area of one circular disc into height h. Height h in that situation will be 10 centimeter, but in this case it is h height. This is total volume. Total volume is area of the base. Area of the base. Area of the base. Area of the base into vertical height. Into this is vertical height, or height simply we write. We can write either height or vertical height, doesn't matter. Okay, so that is the point. This is area of the base is pi r square into h. We write pi into r square into h, but because this is r square, r into h, 3 units are multiplied. As I already clarified that whenever the volume is included, the unit of volume is cubic unit, because there are 3 lengths are multiplied. This is cubic unit, cubic centimeter, cubic meter, etc. Okay, so this is how the volume, third formula is used for finding the cylinder's volume, quantity of cylinder of the volume. Okay, so that is the point here. Now this is the third formula. So this third formula used for cylinder. Now let me take what is the cone here, so right circular cone, or simply cone. Okay, so right circular cone, what is the formula used for finding the questions based on cone, right circular cone. Second topic which we are discussing about is the right circular cone, or simply cone. Right circular cone. This is a right circular cone. Okay, so right circular cone, just like if I take 1/3 part of the cylinder. Okay, this is the 1/3 part of the cylinder's total volume. But out of the cylinder, this is the cylinder here, cylinder with the 2 parts there, and this is third part. So 3 parts or 3 cubes, cones. 3 cones can be taken out, or can be cut out from a cylinder of the same height. Suppose this is vertical height here. In case of a cone, we are having 2 heights. This is known as slant height. This is known as slant height. Slant or sloped one. Sloped height or slant height, which is having some angle. Okay, and this is vertical height. This is known as vertical height, and denoted by h. This is simple h, and this is radius of the base, and this is slant height. Let me take a small l. Slant height is denoted by l in case of a cone. So this is right circular cone. We take A, B, C, D, A, B, C, and D. So CD is the vertical height h, and BC is the slant height, and DB or BD is the base of the radius of the base. Okay, so these 3 things are there. Now we can take that this is right circular, right triangle. CDB is a right triangle, right angle triangle. So right angle triangle means right angle at D point here. CDB is the right angle triangle. So with the help of right angle triangle, we can find out BC, slant height. Slant height is given by L equal to L square equal to by Pythagoras theorem. So this is hypotenuse, and this is one of the 2 sides, this side and this side. So L is equal to L square is equal to R square plus H square. This is R square plus H square in the square root. So this is value of slant height L. We have to use this. Okay, this is one of the point here. Okay, so one of the formula is for slant height, finding the slant height. Then the second formula, let me take second like this. Second form, this is first slant height. Formula for slant height, finding the slant height, is given by this, by right angle triangle, Pythagoras theorem using. Now second formula for what is the curved surface area. This is curved surface area. Now curved surface area. Now in this case we can say that in curved surface area we are taking this pi r, not 2 pi r. The reason is because the top circle is not given here. So pi r into L. Now in this case slant height is multiplied. This is equal to pi r into L. L is the slant height used in case of curved surface area. What is curved surface area? By which a conical the shape is given. For example, a tent is formed, conical tent with the help of some cloths. what is the area of the cloth? That cloth is forming this slant, curved surface. Curved surface of the cone is given by curved surface area of the cone. Curved surface area of the cone, because we are discussing about cone, so not writing cone again and again. So the curved surface area of the cone is given by formula pi r into m, square unit. So this is area. So pi r into m. Why we have to just think about? Because in case of cylinder, there are two circles, bottom and top. So we multiply by 2 pi r, but in this case this is only single pi r, because there is no top is only point. In that way we can remember this. That is another concept for this. But just remember that this is pi r into L. L is length height here. Okay. Then second formula is used. Sorry, third one. Let me take third formula here. Because first formula we are taking for slant height. Third formula is for total surface area. Total surface area. Total surface area is equal to this curved surface area. First is curved surface area. Curved surface area plus this area of the base, plus area of the base. Okay, so total surface area of the cone, that's the total surface area of the cone or right circular cone, no, doesn't matter. We just because we are talking about right circular cone, so not writing again and again by this right circular cone and this and this. So total surface area of the cone. So curved surface area plus area of the base here. Base is a circle, so area of the base. Just write curved surface area pi r into L plus area of the base, which is a circle. So area of one circle is pi into r square. Take pi r common. This is L plus r within bracket. So pi r into L plus r is square unit. This is area, total surface area of the right circular cone. Square unit. Okay. This is the third formula we used. First formula we have taken as for the slant height, L square equal to r square plus h square, or L equal to under root of r square plus h square unit. So this is length height. Okay. So these are the three formulae. Now let me take volume. Now in volume, as I have just talked about previously in the lecture series I think 13. In lecture series 13 I have talked about that why we take 1/3 of this volume, 1/3 of the volume of the cylinder. Why? Because this is a cylinder. Let me take cylinder. This is the cylinder here. Out of this cylinder, we have taken 1/3 part of this. 1/3 part of this cylinder is this core. One part is this, second part is this, and this third part. So total volume of the cylinder, whatever is given, of that volume of cylinder, 1/3 of that is total volume of a right circular cone. So fourth formula, this is the fourth one, volume of a cylinder, of a cone, volume of a cone or right circular cone. So volume of a cone is equal to 1/3 or 1/3 into pi into r square into h, area of the base. Just remember a volume of the cylinder, and 1/3 of that is there. Why? Because this is the third part of the total cylinder. So 1/3 of the total volume, total quantity will be taken, will be accommodated by this cone, okay, with respect to the cylinder of the same height or same radius. If the cylinder and cone both have the same radius and same height, vertical height, in that situation, this cone will hold 1/3 of the total quantity of the cylinder. So cylinder's volume is pi r square h, and this is 1/3 of that, means 1.3 into pi r square h, cubic unit, because this is volume. So these are three formulae mostly used. Okay, so these three formulae we use for right circular cone. Okay, now let us take the questions one by one. As I always say that I will first read the question and after that I'll solve it with the help of whatever the formula is required. Okay, so that formula may be of cone or of a cylinder, and then questions are being solved. So let me take now questions one by one. So all these formulae, I've taken 4 formulae for right circular cone, 3 formulae for cylinder, and then the questions I'm taking. Okay, so all those formulae, 7 formulae will be used, or some of them will be used here to solve these questions. Okay, this is first lecture series based on uh, cylinder and cone, questions based on cylinder and cone. This is one of the first, okay. Second also I'll take, because there are some more questions based on the same topic, cylinder and cone. Okay, so I've taken these 12 questions, after that 12 more questions, or maybe 13 questions, thousands of questions are there, but I have taken important questions so that the topic is clarified. Because my main objective is just to clarify the topic to the students, the people who are seeking, learning, or getting the knowledge of this kind. Okay, so who are entering this field of competitive examinations, and this is one of the, as I've told you, that there are topics which are most important for the examination point of view. Okay, for competitive examination point of view, and this is one of them, cone and cylinder. Okay, and cube, cuboid I've already discussed about. Then sphere and hemisphere, that is also important. Okay, then I'll talk about the first terms. Okay, first term of the cone, first term of the pyramid, and so on. So okay, that is also there, but they are not so important. First term of a pyramid and pyramid, and as the prism, pyramid, okay, and then first term of a prism and pyramid, they are not so important, but these are important ones. Okay, so most of the questions are being asked upon cube, cuboid, cone, cylinder, hemisphere, and sphere. Okay, these 6 topics are most important. Because of that, I have taken more questions based on these. Okay, so now let us take questions one by one. First question is now, for one person, very important question is this. For one person, 94.3 meter cube of air is needed. Now, what should be the surface area of the conical circus tent to accommodate 1000 visitors if the height of the tent is 25 meters? Now come to the point. So it says of a conical tent. So let me take this as a conical tent here. This is just symbolic. Symbolic, this is symbolic, only symbolic. I'm sorry, this is not a proper one. Take the middle, this. Okay, this is a conical tent here. Now in this conical tent, number of 1000 people are to be accommodated, and for one person there is requirement of air, which is 94.3 meter cube. Now in this case, as I have always suggested, that whenever anything is given from the units of that, from that unit what is given there, for example in this case meter cube is given, so it suggests that we have to find out the volume, because volume's unit is meter cube or centimeter cube, unit cube, cubic unit. This is cubic unit here, meter cube. So for one person, 94.3 meter cube of air is needed. What should be the surface area of the conical circus? Now in this case, area of the surface area of the conical circus tent is required, is to be calculated. But in this case, volume is given. So first we have to find out what the volume of this conical tent, because that total volume of the conical tent will accommodate the people, 1000 people. So for 1000 people, how much conical tent will be required? That volume must be equal to the volume of 1 person into 1000 person. Okay, so total volume of the air required is how much? Let me take question number 1 here. This is question number 1. Now it says that one person, question number 1 says, for one person, air required, for one person air required is equal to 94.3 meter cube. This is volume of the air. Now total 1000 people are there, so total volume, total air required for 1000 people, total air, this I'm solving this, okay, so total air, or let me write what is given to us. This is given to us. Let me first write what the given. This is given to us. First is for one person Air required equal to this. Number of persons is also given. How many persons are there? Number of persons of people is equal to 1000. This is also given. And height of the conical tent is also given. Height of the conical tent is equal to 25 meters. Okay. To find what we find here, to find what is the total area, surface area. Total surface area or only in this case surface area only. Curved surface area. Surface area, whenever surface area is given, that means curved surface area. Okay, or curved surface area. Because the conical tent is just framed, there is no base cloth is given. Cloth is just used only for making the conical tent. Okay, tent is being framed by the cloth. So curved surface area we have to find out. This is a curved surface area. Okay, curved surface or curved surface area. This is to be calculated. And given here is that one person requires this much air. Number of people is, or number of persons of visitors is 1000. Number of visitors or number of persons is 1000. Okay. Now let us take the question. So solution. Let me find out the solution here then. Solution here is that total volume of air. Total air required. Total air required for 1000 visitors. 1000 visitors. 1000 visitors is equal to, this is 94.3 okay meter cube into 1000. Why? Because total 1000 people are to be accommodated in the conical tent. So 94.3 air is required, 94.3 meter cube air is required for one person. So 1000 people will require this much air. This total volume, this will be 94.3 2 zeros. Why? The point from one decimal and 2 zeros are further. This is much cubic meter or meter cube. This is the volume of the air. Now this total volume of the air is equal to volume of the conical tent. The volume of the conical tent is equal to this much. This is apparently the volume of the, let me now rub this. Let me solve this here. Okay. So total solution we are finding out here. So total volume of the cone, volume of the conical tent, volume of the conical tent is equal to volume of the air. Total volume of the air required. Volume of the air required, which is there, which we have calculated. Volume of the air required. Okay. Now let me equate this volume to the volume of the cone. But volume of the cone is how much? Or volume of the cone is 1.3 pi into r square into h is equal to this 94,300 meter cube. But what is the height h? Now height h is given to us. H we can write, only r is not given. This is 1.3 into 22/7 pi, value of pi, into r square not given. H is 25 because h was given there 25 meters. Height is 25 meter is equal to 94,300. Now let me take r square is equal to, therefore r square is equal to, r is unknown here, so r can be calculated from this. So r square is equal to 94,300 into 3 into 7. This 3 and 7 will come in the numerator, cross multiplication. After cross multiplication we will get here 3 7 up and 22 into 25 in the denominator.